Hello everyone and welcome to another video. In this one we will start doing our tool to build the project, right? So I've decided to do it in C um, because I don't really need any external um, thing to do it really. I know that we have CMake and stuff like that and make and all of that, but I just want to use C, to be honest. So I think, well, I can refactor this later, but I think I'm going to follow more or less the structure, or it's going to be inspired by the structure of Go projects or Golang projects, because I work with Golang at my daily job, and it's going to be a little bit easier for me to basically follow that, right? So I don't have to like follow two different standards. Yeah, and it's going to be easier. Okay, so I just so I can just create a CMD folder and create a C file. I'm probably going to call it build.c. Yeah, and I can basically start programming it, right? So I think I'm going to place the base.h file inside app, probably. Um, and inside app, I'm going to have all of my internal um, source files, right? And the CMD is just going, each file inside the CMD folder is just going to be a different executable. Okay, so here I can simply include app slash base, right? Yeah, and inside here I can do something like this, right? Um, I think base already includes standard lib no, it does not. Okay, so I need to include standard lib as well, and standard IO, and here I need to define base implementation. Okay, do I want to have, well, I probably want to have options, right? Command line options. I don't know if I'm going to use them in this episode, but I certainly want it, so I can just do something like this, right? So argc and argv. Here I can return exit success. Okay. Yeah, and I think that's everything for now. So what I want to create is basically, well, first I'm going to use this du.c file. I'm going to move it inside cmd, and I want to delete this source folder, and I'm going to change this thing to temp or something like, not really temp, it's more like a probe. I can call it probe because I'm just going to use this file to test things and implementation and stuff like that. So I can call it probe, and I guess I can just implement something that builds, compiles actually probe, right? So I was thinking about using system man clib. I think there, oh no, I don't want any of that. C programming language, this one. So in C we have this function called system that basically accepts, where is it? Okay, it's basically, it behaves as if you forked it and then you waited for the command to be executed, right? But where is it? So basically you can provide a shell script inside, a shell command inside, you can provide a shell command to this system function, and it's basically going to execute it in your system, if I'm not mistaken. And this is part of the C11 standard, so we actually can use it because we are using the C23 standard, and it is inside standard lib. Okay, so the first thing I want to do is to have let me declare an array with the type sharp length. So this is a string, and I'm going to call it cmd, right? So this is going to be my command. Well, I can call it commands. Yeah, why not? So this is going to be my command. In here, I can say void build probe, right? I can build a probe. And inside here I can have my cmd. Okay, so I have my commands, and basically I'm just going to append stuff into it, right? So let me think, what can I say? Well, to build probe, we currently are using this, right? So the first thing I probably want is to have a C compiler. So I can probably have a function like this. So I can say C compiler. I'm going to receive a command by pointer, and here I'm just going to say array append, and I'm just going to append to the command the C compiler. And for now I'm just going to support GCC. It's going to change in the future, but for now just GCC. Okay, so this is my C compiler. Then I'm going to need C flags, right? I'm going to need C flags. So I can say C flags, and I'm going to do the same thing. So I'm going to accept the commands like here, and I'm basically going to append all of this, right? So I can say array append cmd, and I can simply append all of my C flags. Cool. Next thing I want is to define this include flag, right? So I can say include probably, and I can just say this. So this is going to include the third party folder like this. Oh, I made a mistake here. Okay, so then I probably want the link stuff, right? So I can say link, and I can provide this folder to be linked with. Then I need to probably define well, I can say include folder and link folder, and here I can say link relib, right? So I can just link with relib, and for now we are just going to support Windows, but it's going to be very easy to support other platforms in the future. So I can just link where is it, relib, and I can just say, well, I want to link with relib like so, and relib has these two dependencies from Windows, right? So these are kernel dependencies from Windows, and I can do a similar thing and just link with libuv, right? So to link with libuv, I can do this, and then I can link with the system libs that are required, like so. Alright, so I don't think I'm going to need anything else, to be honest. So, and with these functions I can basically just build my command. So here I'm going to say, well, I need the C compiler obviously, and I provide my commands. Then I'm going to need the C flags, right? Then I'm going to need my include folder, I believe. Is it? Yes, the include folder. And then I actually need to append my source file, and my source file is going to be inside cmd/pro.c, right? Oh, and actually I need to also do this, right? Do that. So I actually need to do something like this in here, where I say, well, you can call the executable probe, right? Okay, so after the include folder and the source file, I need to do this with a link folder. Right, so I can just provide this. Then I'm going to need, well, I can do raylib and libub for now. I guess that's just fine. So I can say libub, or actually raylib and then libuv. Okay, and I think that I can call this probe cmd, right? Or probe build cmd, and this is going to return me a command, right? Okay, so basically this function returns me the command that builds the probe source file. Okay, I think that's reasonable. And now I probably want another function. That executes cmd or something like that, that basically receives a command and executes it, right? And in this case, this is a command is an array of strings, right? And we need to concatenate them into a single string. And I think that for now I can probably just use an allocator, probably. So I can just say arena. So this is my arena. Well, actually I can probably define a global arena and use the global arena everywhere. So here I can say cmd.options.allocator is equal to arena, right? So I'm going to use my arena to allocate my command. Okay, I think I need to cast it to allocator probably, right? Okay, so now we need to measure the size of the string we need to build, right? So one easy way to do that is to have something like this. So string size, or a string builder size, or something like that, I don't know. You can call it many names. And then I can say something like array for each, and here I'm going to provide my cmd, right? Oh, I'm going to provide my cmd, and actually something very simple. First I need to include string.age, right? And basically to my string builder size I need to add strlen of the current string in my command, right? But I also need to add spaces. Because otherwise this would be glued together and it would not be a valid command. So how many spaces do I need? So every time I have a string, I need one space at the end of that string, right? So I basically can just add one, and that's going to be more than enough, right? More than enough space to build our commands. So now I can basically just say arena alloc, and I can provide my arena. And how many bytes do I need? So I'm going to basically need this amount of bytes, because each character is a single byte, right? And here I can just say this is going to be my command sister or something like that, right? Command cstring. Well, I can just call this C string size, right? Okay, and I can just call it C string. Okay, so now we need to append or copy actually all of our data into our C string, right? So what are we going to need? We are going to need basically another variable. We can call it C size t, and you can say sister index, and the starting index is going to be 0, and then we loop through our command once again, right? And here inside in the body we can just say that C string, well, we are probably going to use memcopy, right? I think it's better, or memmove or something, whatever. Memmove is safer, but yeah, you can use memcopy, it's faster, or yeah, whatever. So we are going to use memcopy, and this needs a destination. So the destination for memcopy is going to be C string at index that, and we need a pointer to it. Then we need the source, and the source is just going to be the value of my iterator, very simple, and the length is just going to be the length of my iterator. Okay, so we basically just copied my string, in the current string in my command, to my C string, right? And I need to increment the C string index by this length. So I can say something like size t. I can say that the length is equal to this. Oh, is equal to this, and here I can just provide length, and here I can put length, right? So we increment this by length, and then I need to append white space, right? Or actually a space. Any white, no, yeah, it needs to be a space because commands don't work with new lines, right? In this case, so I can just say C string index plus plus is going to be equal to a single space, and this is going to be basically build my commands, or concatenate my command into a single C string. And I think we can already execute this one. Basically, well, I can say something like printf execute, or I can say something like cmd, and I can just provide this, right? And I can just say C string, and then I can call system, exactly system, and this is going to be my C string, right? And I actually want to check the error codes because it's probably important, because we may build some incorrect commands sometimes, but whatever. So then whatever is not probably never going to be null. Could not be retrieved. The return value is -1, and error we set to be indicate the error. It could not be executed the shell process. Then the return value is as though the shell terminated by calling. What's it? Okay, so I basically just need to check, from what I understood, if system, then we need to report whatever is inside error. Right, I think that's what it was telling us. So I can just say error, right, and then I can just say this, and then say str error, and provide error no. And after this we probably want to exit, I think, and then exit with failure. Okay, so this is my execute commands function. It basically executes a single command. So let's use it and test this code. So I'm going to execute the probe build commands and see how it goes. Oh yeah, this needs to be, well, I probably don't need this to be a pointer, to be honest. I don't know why I put it a pointer. Yeah, because we are not going to modify the command, so yes. Yeah, I think that's everything. So let's see how this goes. So now the only thing that we need to bootstrap our build system is to compile it, right? So I can just say, well, I can just say all of this like this, paste. Oh yeah, let me see. So can I? Oh, I cannot. Okay, so let me just say gcc minus o, and I'm going to say this is going to be called build. Then I need to use the same standard because we are including base.age, and base.age depends on C23 standard. Yes, I can be pedantic. I probably want to do some optimization. Let's see how this goes. And I just need to provide the build.c file. And I think that's enough, to be honest, right? So here, if I execute build, why do I? Oh, okay, because I build.sh, so I can probably delete it. I don't need it anymore. And I can just execute build. Okay, so line 287. So we have some problem in 287. Where is the line 287? Oh, realloc. Yeah, that makes sense. Because we never implemented realloc in Arena. So let's do it, right? Let's do it. We can just say this, and this is going to be realloc. And realloc, what is the signature of realloc? It's this one. Okay. It's this one. Okay. So we have realloc. And this is going to be extremely simple, right? I'm not going to. This is meant to be fast, right? And if we waste a little bit of memory, that's just fine, right? For now, if in the future we have some complications, we can use a different allocator. Okay, but this bump allocator is not going to do anything special when we try to realloc. It's just going to allocate a new block size and copy the previous data into it, and it's not going to free anything. Okay. So what we are going to do is basically call arena alloc, and it's going to allocate in the same arena the new size bytes, right? Oh, where is it? Okay, and this is going to be my result, and and what I need to do is now mem copy, and I have the guarantee that this pointer is never going to overlap the previous pointer, so that's fine. And do I include string? I do not, so let me include string.age in here. So I just include string.age, and here the destination is going to be the result. The source is going to be the old pointer, and the size is going to be old size bytes. So we just copied that. And here I can actually say something like this, because this returns destination. And since this returns destination, I can do something like this, and boom. This is my realloc implementation. It just allocates a new block and copies old size bytes from old pointer into the new region, right? So now what I need to do is probably define this in my other portion of this. Where is it? Okay, so I probably just need to do something like that, right? And in make arena I need to set it to have a correct pointer, so I can just say arena allocator realloc, right? And this is going to have the same signature in here, like this. So yes, we need to just cast the pointer, and then we can call arena realloc with old pointer, with old size and new size. Okay, and then we just set the correct function in the header, right, like so. Okay, so I probably, yeah, I forgot that I no longer can use this because this is always going to fail. What I need to actually use is make arena. So let's make arena. Okay. And since I need make arena, I probably, instead of using a global variable, right, I can just say arena, arena, and then I can provide arena as a parameter. Probably that's better approach, I don't know. So arena, right, and this doesn't need anything because the allocator is going to be defined inside the collection itself. Okay, so here I can just provide a pointer to arena, and same thing here, right. Well, I could accept an allocator here. I could accept it, well, but whatever. It could be more generic, but yeah. So we need to build the build script once again, and this has some problems. Okay, so I made some typo here, yeah. And okay, so we build it, and let me execute the build script, and we have a seg fault. Okay, that's not good. So let me see where is the seg fault happening. So if I do something like this, does this work? Let me build and execute in the same thing. Okay, so the seg fault is not here, right? It's not in execute command. Oh, it's probably here. Yeah, because I'm providing a pointer and this, okay, yeah. This probably makes me think that it's probably better to do something like this, right? And I just provide a generic allocator here, and same thing here. So I don't have to cast stuff, and this function works with different kinds of allocators. And here I can just say alloc, and I provide my allocator. So this is going to work with any allocator I provide it, right? And here, yes, I think I can just pass arena. Yeah, and it's going to manually automatically cast. Or maybe not, let's see. Yeah, I need to manually cast it. Okay, so I can just say allocator this, and same thing here, this. Okay, so I probably can just do allocator, and I can just say this, just to be a little bit more clean to the eyes, right? Okay, so let me build this. Okay. Wonderful. So it did actually build. I don't know if you realized it, but if I execute build.exe, right, this is going to print my command, right, and then it fails. Well, why it says no error? It prints an error, of course, but it says no error. Why? If the shell cannot. Okay. The return value is a wait status that can be examined using the macro described. Oh. I'll need to take a look into it, but okay, let me just first fix this, because probe now needs to go into app, right? We're going to use app base.h, and this should be the fix. Okay, and it executed. So there is some specific, let me remove all of this. Okay, so there is some specific, where is it? Oh yeah, because demo also, yeah, specific error status for stuff. So could not be executed in the shell process, then the return value is of the shell calling exit2 with status 127. Okay. I don't feel like taking a look at this right now. So if the shell process, so this is not what we want, right? Well, yeah, we can probably improve that later. I now want to focus on converting all of my current project into this model, right? So let's move demo.c into CMD, right? And we can already delete demo. Okay, and here this needs to go to app once again. So we have app base, and this already works. So now inside my build.c, I can probably have a command that builds demo, right? So I can say cp probably demo, and I can keep everything else the same, even though I don't really need relief. Yeah, I may not link with relief or lip uv, because demo is like more to demonstrate the behavior base.h. So yeah, I can use probably just relief and lip uv out, right? And then I can also execute the demo build command, and this should work. So let's see. And I need to recompile my build script, my build executable, right? So okay, as you can see, this executed two commands. The first one to build probe, and the second one to build demo. Okay, and if I execute demo, this executes the demo. If I execute probe, this executes my probe. Okay, and last thing I want to do is to move this app.c into the CMD folder once again. And my app.c, this is, I can rename it to client. So I can say that this is going to be my client. And yeah, this is basically the client. It doesn't have that much stuff in it for now. And then I can probably build my client. I can just call it client, like this. And the client will need relief and libuv. I am sure of that. And yes, I think that's everything for now. So I can just copy this and change this to the client. And so this build.c file is now going to build probe, demo, and client commands. And yeah, we can in the future accept, well, I can probably say something like void argc for now, and void argv. And in the future we can accept parameters or command line arguments, and like pick different executables to build, and like release modes or debug modes and stuff like that, and that is going to manipulate the flags we pass into the C compiler. And you can probably pick like, or you can use macros like if def underscore win32, then use, I don't know, use like the msvc and whatever, right? Whatever. So we can pick different compilers and stuff like that at compile time. And yeah, I think that's everything. Let me just then compile this and run my build script. So this also builds the client. Okay, as you can see, we executed 3 commands: the first one, the second one, and the third one. The third is the client, and everything is just fine, right? Everything is just fine. If I execute the client.exe, this is going to open a window and it's going to say welcome to Dear Universe, and that's it. Okay, so I think that's everything I want to do in this episode. Yeah, in the next one we will be probably cleaning up all of this base.h file in preparation, and we are going to refactor it a little bit, right? In preparation to start programming the actual game, right? I know we spent like 11 or 12 episodes like just preparing to start programming, but this is C and I don't want to create a mess, because yeah, this can go out of this can derail very quickly if we are not careful, right? Because we don't have access to any data structure in C. We need to program everything by hand, and this is a game, so the lifetime of the objects is going to be easy to collect, like in air quotes, using allocators. So this is, I think, the minimal thing I would like to have to program a game in C. So allocators and data structures. And that's it. So thank you for watching, and I see you in the next one.